Okay, greetings once again, guys, and welcome to another edition by iCampSA. This edition, we're looking at part 4, which covers questions 8, 9, and 10. And this part is focused on Euclidean Geometry part of the paper. We're still looking at the June 2025 exam paper 2, which was written in KZN. This is grade 12 maths. So let's go ahead and have a look at question number 8. So question 8, we are given the diagram and we are told that angle C is 26 degrees, okay? And we're given all the parallel lines which are labeled. So let me go and label this angle C, which is 26 degrees, okay? Then they say write with reasons other angles that are equal to 26 degrees. So let's go ahead and have a look. So 8.1. So if you look at this angle carefully, you will realize a couple of things that you should have learned. So if you observe carefully, angle B1 should be equal to angle C because these are angles in or subtended by the same arc or angles in the same segment. So angle B1 is equal to angle C, of which, if you observe carefully, that is 26 degrees. And the reason is angles in the same segment. So let's note that in the same segment. Okay. Others would have said angles subtended by the same arc. Just review your basic, what you call it, Euclidean geometry. Right. So let's carry on. What you should be able to see is another angle. If you observe carefully, if you look at that, and that, so there's an angle which is E2. So you will see that actually E2 is the same as B1, which B1 we found is 26. And the reason why E2 is B1 is because of, if you look carefully, there's a Z here. So the reason why these are equal, it is alternating angles. So we're looking at alternating angles, okay? But if you observe carefully, these lines are still parallel. So let's go with pink, this, that. So we have another alternating angle. So you will be able to see that your angle A2 is equal to angle C, which is equal to 26 degrees. Why are these equal? It is because of alternating angles. Okay. So they said 3 other angles that are equal to that. So we're missing one more angle. The missing angle, if you observe carefully, it is B2. So let's have a look at this triangle. So if you look at the triangle OBE, let's just, if you have a look at triangle OBE, you will see that the angle B2 equals angle E2, okay, because this is radii. So these are just angles opposite what you would call equal sides, okay. Angles opposite equal sides are equal, okay. So that is why these are equal. Just write your thing in full. So you will see that therefore our B2, we have found our E2 already to be 26. So this becomes 26 degrees. So we have all the marks. So you have your 3 angles. These are your angles here, and you get marks for the reasoning. Okay. So I hope that this does make sense. So let's go and have a look at the next question. So the next question is 8.2. It On 8.2, we are required to determine the size of O1. Right. Let's have a look at what is happening with O1. So what you should be able to see is that O1 is an angle that is at the center. What do I mean? Well, if you have the line here, or if we draw a line, let's draw a line here at BC. Okay, so you will see that this line here is looking at the center of O1, but looking at the circumference of E2. Okay, so what does this mean? Well, if you remember the theorem, angle at the center is twice the angle at the circumference. So angle O1 is the same as 2 times E2. And the reason for that is very simple. Angle at center, that is equal to 2 times angle at the circumference. Okay, so that is the reason that you should give. Just try to write everything in full. So this means that our angle O1 will simply be 2 times 26, of which we will end up getting 52. So therefore, angle O1 equals 52 degrees. Okay, hope you guys understand. Right, so let's go and have a look at 8.3. So for 8.3, we are required to determine BDE. So let me go and label that BDE. So we are looking for BDE. It's this entire angle. Okay, so let's go ahead and have a look at how do we then find that angle, BDE. So let's go ahead and find this angle. We're looking for the angle BDE. What is it? But if you notice carefully, we were told that we have CE as the diameter. So if CE, let's erase, if this is a diameter here, what it means is we form a right-angled triangle at A1. Okay, and this is going to be very useful in us figuring out what is happening. So what you should be able to see is that the angle A1 equals 90 degrees, and this is an angle in a semicircle because CE is the diameter. Okay, so with A1, if you look carefully, we have the entire angle A now, which is angle A1 plus angle A2, okay, which is just the A1 we found above. It's just 90 degrees. A2 is 26. So this ends up giving us 116 degrees. Okay, so now that we have 116 degrees, you should be able to see that, we can look at this slightly differently. So what we have here now becomes a cyclic quad. If you look at my green. So what do we know about a cyclic quad? Opposite angles of a cyclic quad are supplementary. So angle A plus that angle there, which is BDE, those should be 180 degrees. And this is just opposite angles of a cyclic quad. They are supplementary. So they are sub. In other words, they add up to 180 degrees. Okay. So that is the reason there. So with this in mind, we can now go ahead and solve because we have 1160. So we have 116 degrees plus BDE. And this equals 180 degrees. So we just need to transpose. And you'll see that your BDE will simply be 180 degrees minus 116 degrees. of which what we end up getting is 64 degrees. Okay, so this here becomes our answer for this question. So that brings us to the end of question number 8, guys. Let's go and have a look at the next question. It's question 9. So 9.1 I'm not going to do because it's a general proof question. So it should be available in your notes from school. So let's look at 9.2, where we are told the diagram below L is a midpoint, or L is a point on the side KM of this triangle. So we are told all of this. Then let's have a look at what they are asking for. Determine the ratio of KL over LM. So KL, which is just AK, which is that, over LM, which is just over that. Okay. So that should be very simple for us to do because the other side has sides that have been split by a parallel line. Okay, so let's go ahead and see what is happening. So what this means is, if we look carefully, 9.2.1, if we're looking for KL divided by LM, this will be equal to NP or PN divided by our NM. Okay, and the reason which you can give here is that the side that we are looking at there, it is line parallel to one side of a triangle. So when you look at your solutions or your class notes, you will be able to understand what we mean. So it's a line parallel to one side of the triangle. Okay, so that is what is happening. And now we know the values that describe the side here. So let's go ahead. So what we essentially have is 12 divided by 20. Okay, and that is all what you needed. So therefore we can simplify that. Our KL divided by LM, that will be, there's a common factor of 4. If you divide by 4, you'll get a 3. If you divide by 4, you will get a 5. So that becomes our answer. So this here is our answer. Okay, so let's move and have a look at the next one, 9.2.2. Okay, so we are required to calculate the length of PQ. What is PQ equal to? And for this, what I'm going to do is to be very careful in approach. Okay, so what I'm going to do is I'm going to call this side 12x, then I'm going to call this 20x. Okay, and then the other side, I'm just going to name it in terms of y's. So we have 20y. So maybe let me copy it and then come to the other side. Yeah, let's deal with this here. Hopefully it will just click and make sense to you guys. So what we are going to do is we are just going to call the side here 12x. Okay, from there to there, then from here to here, that will be 20x. Okay, and then now obviously from there, this entire thing, you can have a look. It's gonna be 20 plus that. Let's just put in the x here, 20x. So 20 plus that, that's gonna be 32x. Okay, so let's also do it this side. So this side, I'm going to have 20y. Then I'm going to have 12y, like that. And then what I'm going to do is for this entire thingy, I'm going to have 32y. Okay, like that. Now we need to think carefully what is happening here. Okay, so we're looking for the length PQ. Now, the first thing that we can do is to figure out what is PQ, in proportion. What do I mean? Well, if you observe carefully, there's two parallel lines here. There's a line here and a line here. So what does this mean? So it means PQ divided by, if we just take the same order, divided by PM, that will be the same as, if you observe carefully, KL divided by LM. Okay, this we already know, it's 3/5. So this essentially means I have PQ divided by our PM is 32y. Okay, and this will be equal to, if you observe carefully, 3/5. Okay, and now we can multiply such that we get our PQ. So our PQ will be 3/5 multiplied by 32 times y. Okay, so which means our PQ is simply, I don't think that will divide. So the answer, you will see that it will be 96 divided by 5y. Okay, but if you look at our y, according to the scale here, our y is 1. So if you just equate one of these, you will see that our y is 1. So, but if you take one of them, you'll see that 20 equals 20y, which therefore means that y is 1. So if y is 1, then this becomes a very simple problem. So if y is 1, therefore our PQ will just be 96 divided by 5 units, which if we just show into 2 decimal places, that will be 19.2 units, whatever the units are. Okay, I hope that you guys are able to make sense of this. With that said, let's go and have a look at the next problem. So on this one, we are required to determine the ratio of KQ. Let's figure that out. So we are required to determine the ratio of, let's have a look, KQ, so which is that, divided by LP. Okay, so let's have a look at how do we deal with this question. So the first thing that you need to realize is that the two triangles that you are working with, if you're looking from this direction, you have this side LP and then you have that KQ. So what I'm going to do is just put in angles that are going to be equal. Okay, so that angle is going to be equal to that because of corresponding angles. Okay, and this angle here, the purple on triangle KLP, is going to be equal to that. Okay, and you will see that we are then going to have a common angle, which is angle N. Okay, so we can go ahead now and quickly put these sides in proportion. Okay, but what you should be able to see is that triangle, if you observe carefully, I can start wherever I want, to be honest, We can start at K. So triangle K, QM, the bigger triangle. If you observe carefully, it will be similar to, so since I started at K, I must now come and start here. It will be similar to triangle LPM. Okay. And the reason is very simple, angle, angle, angle. Okay. With now this in mind, we can therefore put these sides in proportion. Okay. So if you observe carefully, you can take this one over this one, or you can take KQ, then you'll divide it with LP. Okay. So you'll see that you'll have KQ divided by LP. And this will be equal to QM divided by PM. Okay. And this will be equal to KM divided by LM. KM divided by LM. Okay. So let's go ahead now and have a look at what we do have. So what we do want is this proportion here. Now the question we need to ask ourselves is, do we have these ones here? Do we have a QM dividing a PM as an example? Now this should be very easy to figure out, because remember, and you can even use the other side where you have, if you remember, this was 20y like that, and this was 12y, and then the entire thing was 32y. Okay, so you can use either one. So we can just take this one and that one if we want. Okay, so let's go ahead and maybe use those. So if you look carefully, KM is going to be 32. Okay, so that means we are going to have KQ divided by LP. So KM is 32y divided by LM. LM is 20y. So if you go to your calculator and do 32 divided by 20, what you end up getting is 8/5. Okay, so that there is what you end up getting. And why are we able to set these to be like this? What we can note is this we can do because we have similar triangles. Okay, others would call that your proportionality theorem. So that is what we are supposed to get for this question here. So therefore, let's put this up. Our KQ divided by LP, that is 8/5. And this here, guys, becomes our answer for that question, 9.2.3. Okay, very simple question. I hope you guys understand. Right, so let's go and cook the next question then. So let's move it a couple of pages back. Let's leave it here. Right. So the statement reads, in the diagram, O is the center of the circle B. They're just telling us the edges, if you look carefully, it's BC, EF. Okay. Then they tell us ABD, that is the tangent, and they give us parallel lines, which they then indicate. Sorry. Let's move it up. They give us parallel lines, which they also indicate here. But let's go and read what we are required to prove here. So the first part, we are required to prove that BG is equal to EG. So let's quickly highlight what is required to be proven. So BG there is BG. That should be proven to be equal to EG. Okay. So if we can prove essentially that OF bisects or forms a 90 degrees, then that is enough for us to consider that as a proof. Okay. So let's go ahead and do that. So what we can first do is to look at B3. So remember that this is a diameter. Okay. What we have here, this is a diameter. So let's go to 10.1.1. So remember I said here, what we can do is if we can show that G1 equals 90 degrees, then what that means is that OG bisects your BE. Okay. And what then this means consequently is that our BG will therefore be equal to EG. Okay. So we are relying on proving that G1 or G2 equals 90 degrees. So if we observe carefully angle B3, that should be 90 degrees. That is an angle in a semicircle. Okay, so that is why that becomes 90 degrees. But remember, we are then told that we have parallel lines. Look at that angle and that angle. Simple grade 9 mathematics. Angle G1 is equal to angle B3, which is equal to 90 degrees. Why is that? This is because of corresponding angles. Okay. So as you can see, G1 is therefore equal to what you would call it 90 degrees. So this means we are making a 90 degrees angle there. So we can then conclude on this very easily. So therefore, what we can say is BG is equal to EG. And the reason why we can say so is the line from the center is perpendicular to what you call it, your chord. So your line from center is perpendicular to your chord. And if you remember, then the converse would then say that your line, if the line from the center is perpendicular to the chord, it bisects the chord. So that is the rationale which we are using here. So that there would be sufficient. You would get all the marks. And really the idea is you are supposed to recognize this. Okay. So let's go for the next question, which is 10.1.2. So we are required to prove that what we have is a cyclic quad. So let me quickly just focus on this here. So what we are told is that we have A, so we have A, E, and then OB. So A, let's quickly note that A, E, O, and then B, like that. Okay. So we are told that we need to show that this here will end up forming a cyclic quad. So we guys should know how a cyclic quad, fundamentally behaves. So you're looking at opposite angles being supplementary and so on and so forth. So now the question is, which angles can we show that they are supplementary? Okay. And if you look at this, the easiest one, or you can use the exterior angle of a cyclic quad. That is another thing that you can possibly use. So if you observe carefully, there's a couple of things that we have at our that we are exposed to, which we can use. So we can either go and try and show that this entire angle plus that one, that will give us 180 degrees. Or we can go and try something else. So let's quickly label some angles that are equal. It makes our life to be a bit easy. So if we can look at the parallel lines here, let's make a note. Look at these parallel lines here. They afford us a lot if you look at the original function. So you'll be able to see that this angle here before corresponds to that angle. Okay. But before, again, because BD is a tangent, it also equals that angle. Okay. But because we are inside the circle, this angle also equals that angle. Okay. If you observe carefully, no, so the other part doesn't touch there. So let's remove that. So if you observe carefully, guys, our proof is actually good as done, because you can only have this equaling that in a cyclic quad setting. So let's see how we can write this formally. Okay. So let me see if this is just gonna move with my things. Yeah. So let's go ahead. What I'm gonna do is to set, let's say, before to be equal to x. That is a dummy variable. So the first thing that we need to realize is that before is equal to, if you observe carefully the original circle, before will be equal to angle E. Why is it angle E? That is because of our tan chord theorem. Okay. But also, if you look at corresponding angles, as I said, your B4, which all of this will be x, your B4 is also equal to your angle A. The reason why they are equal, it is because of corresponding angles, of which that will be x. So you will therefore see that angle A and angle E are equal. So now, if you think carefully in this setting, this therefore satisfies the conditions that you would be having for a cyclic quad. Look at what I mean. So if you look at this now, you will see that those angles there are equal. So we can conclude that what we have is a cyclic quad using the converse, because what we are saying is if AEOB is a cyclic quad, then these angles are equal. Now what we are saying is if these angles are equal, therefore that is a cyclic quad. So therefore your AEOB is a cyclic quad. And what we are doing is just using the converse. So what would be the converse? For a cyclic quad, we would say these angles are in the same segment, or they are subtended by the same arc. So converse of angles subtended by the same arc. Okay, so that would be our reason. Okay, so I hope that does make sense to you guys. Let's go and have a look at the next set of questions. Okay, so let's have a look at this one. So we are required to show that the two triangles are similar. So let me see if I can highlight these triangles. So we're looking at OEB. So OEB, let me see. Sorry, OEG. So we have OEG, which is this one. And we are trying to show that it's similar to BAG. So we have B and then A, and then G. Okay. So this should be very simple because of what we had done on the previous page, guys. If you remember, we figured that we actually have a circle here, right? So let's try and just put it properly. Yeah, we figured we have something like this. So this is what is going to make our life to be easy. So we're looking at 10.1.3. So I need you to remember that what we have there, A, so AEOB is a cyclic quad. We did show that on the previous question. So with this in mind, we can go and do a couple of things. So let's have a look at what we can do. So we can see that angle A is equal to angle E. Okay, and these are angles in the same segment. Okay, it's just these angles there. Okay, let's just use color for them. So that angle and that angle, they are equal, they are in the same segment. Okay, but then what you also need to realize is that A angle B G is the same as, if you observe carefully, E angle OG. And these again are angles in the same segment. Okay, done with that. Then you will see, so this speaks to this angle and that angle. Then you will see that the other two angles will be equal. This is grade 9 reasoning. Okay, so you will see that angle G3 will be equal to angle G1. And these are vertically opposite angles. Okay, so we have shown now that this is that because we have three equal angles. So we can conclude, therefore, our triangle OEG is similar to triangle BAG. Okay, so done with that, and the reason is angle, angle, angle. Okay, so I hope that it does make sense to you guys. So with that said, let's go and have a look at 10.2. So we are told if BC is equal to 10 units, and AG equals 35 units, calculate the length of OE. So let me see if I can quickly label this sketch here. So see, move, let's cut you. Okay, so let's quickly see what is happening here. So we are told that BC, so where is BC? Nearly cut you, so let's extend that. So we are told that BC, which is just this side here, is equal to 10 units. So just gonna do this. So our BC equals 10. Okay, so I'll just call that 10x. Okay, and then we are told that AG, so here is AG, let's just use a different color. So AG we are told that that is 35. And then what we are now required to do is to figure out the length of OE. Okay, you quickly highlight OE. Where is that? OE, which is that. Okay, so there's a couple of ways we can go about dealing with this problem. So let's go ahead and deal with this. So I don't need to put X here because this is units. So if you do remember, you'll remember that here what we have is the radius. And according to our midpoint theorem, and this is very important, once you have two equal sides here, we can use the midpoint theorem. What does it say? It says that our OG will always be half of our BC. So let's go ahead. So what we'll have is our GO will be half of our BC. Why? It is because of our midpoint theorem. Okay, so which means our OG will simply be half of 10, which will be 5 units. Okay, so for OG we now have 5. So let's go ahead and put in our 5 here. Okay, so we have our 5 here. Now we need to figure out how can we then use all of this to be able to figure out what is OE. So as part of solving this problem, what we need to realize is the angles that are equal. So if you look carefully, you'll have that angle equaling that one equaling that one, just purely on the parallel lines, and that one equaling that one. So that means we can put sides in proportion here. And we had in part had done that, but let's have a look at just the statement before our thingy. So if you look at the fact that we have triangle, let's use this one. So you'll have OE divided by BA or AB. So divided by AB. Sorry, it's going to be BA divided by BA, and this will be equal to, now you can jump and do EG. So you'll have EG divided by AG, and you'll have OG divided by, if you observe carefully, BG. Okay, so let me take this to the next page and we'll try and continue that side. Okay, so if you observe carefully, what we are looking for again is EO or OE. So we can just keep this portion here. So we can keep this portion because that is what we are looking for. The OG element we can keep because we actually know what OG is. Now, what we are going to do is let's think in terms of the other triangle. So this one here with similar triangles. So let's have a look at the two triangles that I've just shaded now. So if you look carefully, that is triangle EOG, and that is similar to triangle ECB. Okay, so let's quickly put these in proportion. So what you see is that you'll have EO divided by EC, and this will equal to EG divided by EB, which will be equal to OG divided by, if you observe carefully, CB or BC. So what does this say to us? Remember, we're looking for OE. So this ratio here, we actually do have, because we have OG, which is 5, and BC. So that there is just 5 over 10. Okay. So that then leaves me with EO over EC equaling 1 over 2, which means our EO is half of EC. Okay, so if we can figure out EC, then we would figure out EO. But if you observe carefully, guys, these results, they really just tell us that our diameter is just your radius, which is OE, is just half your diameter. So we then clearly need to go back to that arrangement there. Okay, so if we go ahead and we look at the two sides, this one and this one, we can rearrange by multiplying both sides, such that what we end up having by cross multiplication, essentially, you'll end up having your GA or your BG, the other side, so you'll end up having BG times, if you observe carefully, it will be EG, okay, and this will be equal to OG multiplied by, if you observe carefully, AG, okay. And if you look carefully, your BG and EG, let's have a look at what is happening. Your BG and EG, those are equal. So we can just make them one of these. So we can make it EG all squared. And EG all squared equals that OG times AG. And if you observe carefully, OG we found is 5. So that becomes 5 times 35. Okay. And you will see that the answer which we end up getting here is 175. What this means is that our EG has been found to be square root of 175, which is the same as 5 square root of 7 units. Okay. Now, how is this EG going to assist us? Well, if you observe carefully, you'll be able to see that we can use Pythagoras if you look at the triangle that is in pink. If you look at the pink triangle, we can use Pythagoras. So our OE squared will be the same as our OG squared plus our EG squared. This here is nothing deep but your Pythagoras theorem. Okay. And you will see that our answer will be our OG is 5 squared, then plus you have 5 square root of 7 all squared. This here will end up amounting to 200. That will be our OE all squared. So therefore, if you square root, you will see that your OE will be the square root of 200, which is the same as 2 times 100. So that should give you 10 square root of 2 units. Okay, so we can round off this to 2 decimal places where we are going to have our OE equaling, they say 2 decimal places. Well, they didn't specify. So our answer becomes 14.14 units. Okay, so that is what we were supposed to do for this question, guys. I hope that it does make sense. So this one here comes from this previous problem that we worked on. So for us to have this conclusion, it just stems from this here when we were proving that. Okay, so I hope that you guys understand, and this lesson was brought to you by the awesome iCampSA. So please share We hope you enjoy, and all the best in preparing for your exam. This is part 4, questions 8, 9, and 10. Cheers, guys.